Hello everyone, we are solving problem number 33, search in rotated sorted array. So what rotated sorted array is, let's take an example. 1, 2, 3, 4. So if I rotate this array by 1, it will be like 1, 2, 3 and 4 will come at start of the array. So if I again rotate this array by 1, it will be like 4, 1, 2 and last index 3 will be at here. Okay. So this is how rotation in array works. So also if we have given a target element and we need to find index of that element in that rotated array. So if we are given an sorted array, we will just run binary search. But in this case, we cannot directly run binary search as this array is not completely sorted. It is sorted till some point, and then it is sorted again till some point. But as a complete piece, it is not sorted. So in my one of previous videos, I have solved peak index problem. So we are going to use that problem, use that application here also. And also there is also one hint. They have asked us to solve it using login. So when you see login in any problem, the first thing which should pop in your mind is binary search. So let's just try run this problem. Okay. So this is an rotated sorted array. So what we will do is, what we have done in peak index problem is, suppose our middle element is this. So we were checking the next element and shifting our start and end pointers. But in this case, the array is sorted in two parts. So we will check the middle element and the end of array. So we will check is 0 greater than 3? No. Then we know our peak index is going to be in the left side of that array. So okay, so I will just make a I will just in the first iteration I will just find a peak index. Okay, so let's make some variables. In start equal to 0 and end is equal to nums dot length -1, and let's make one variable called length because we are going to need it in multiple occurrences. Okay. So now, and we will also make one variable known as a peak index, which is, let's say, integer, or we can just declare it as -1. Okay. So let's make a loop. Start less than end, int mid is equal to start plus end minus start divided by 2. Okay, and we will just take if nums of mid is greater than nums of mid plus 1. Okay, so we need to move to the left, so we'll make end is equal to mid, else we will make start is equal to mid plus 1. Okay. Now yeah, so we have gotten our peak index. We will just mark it, and for understanding purposes I will just log it. System dot out dot println peak index. Okay, the code will give an error because we haven't solved the afterward part, so we'll just run it. Okay, so we need to 3. Okay, 0 1 2 3. Yeah, so we are getting the peak index. Now we can divide this array into two parts, which is this one, this sorted part, and this sorted part. Okay, so I will just remove it, and I will redeclare start and end. N is equal to 10 minus 1. Okay. So now, as we have divided that array into two sorted parts, so we can just apply binary search. So I will make one function instead of doing it twice. We will just make one function. What is int binary search? It will take 3 arguments or 4 arguments. Int start, int end, and int target. Okay, we are mentioning start and end because we are going to solve it in two parts, so we need to mention our starting and ending index of those two arrays. Okay, so let's just make one while loop. Start is less than equal to end, int mid is equal to start plus divided by 2. Okay, and we will check if thumbs up mid, so we will just return mid, else if thumbs up mid is greater than target, so thumbs up mid is greater than yeah, so we just need to make end is equal to mid minus 1, else start is equal to mid. Okay, if we don't find that element in this array, so we will just return minus 1. Okay, so we will use it here. Let's make one variable called result is equal to, let's say, minus 1. Okay, and we will just make two binary search calls in those arrays by the condition. So what we will do is, we know this part is sorted, so we will check if the last element is greater or smaller than target element. If our target element is smaller than this last element, so we need to search here, else we need to search here, because these elements are greater than this element. Okay, so we will check if target is less than equal to nums of end. So what we will do is, result is equal to binary search nums, start will be at peak index, then end will be end, and target is going to be target. Okay, else our result is going to be binary search nums, it will be from 0 to peak index minus 1 and target. Okay, so let's just return result, and I think everything is good. Let's try to run this code. Okay, line number 28. Oh, here. Yeah, everything is good now. There was a small syntax error. Again, here line number 33. So have I made any syntax errors? So let's check them. Okay. Hmm, while loop. Okay. Hmm, okay, it's running. Let's try to submit this code. What happened? Output -1 expected 0. Is it in-house or in-house? Oh, 1 3 target 1. So I will check this code once. Okay, here it should be start, and okay, let's check now. Okay, why we are not getting the answer? Start is less than equal to end. So let's make one case. Names of start is less than names of end. So in this case we will just return binary search names of names start end and target, as in this case array is sorted. Okay, so now here also I have made one mistake. It will be mid plus 1. Okay, and it should be less than 8. I will explain you why. Because check it here. Suppose our middle index is 0 and our end is 2. So we will check if end is greater than this element. So if it is, we need to move on the left, because peak index is going to be on the left side of that smallest element. So for that reason we need to make those two changes. I have debugged this code and found those problems. So let's try to run this code now. Okay, it's running. Let's try to submit it. Yeah. Why we are not getting time complexity? Okay, thank you.